Continuing with the unit number 6, that is templates. In today's session, we are going to learn about runtime type information in C++. Then followed by a program which will show the runtime type information, and then code demonstration on code block, and then if we have time, we will have a question answer session. So let's begin with the runtime type information. Okay, in short it is called as RTTI in C++. That is runtime type information. So in C++, runtime type information is a mechanism that exposes information about an object's data type at runtime and is available only for the classes which have at least one virtual function. It allows the type of object to be determined during program execution. Again, same concept in other words. In C++, the RTTI is a mechanism that expresses information about objects data time during runtime, and this feature can be available only when the class has at least one virtual function. So this feature exposes the information about the object's data type during the runtime. It allows the type of object to be determined when the program is executing. Or in simpler words, it will decide the type of the object when your program is in execution. For example, dynamic cast in the followed program uses the RTTI and following program phase with error cannot dynamic cast B of type class B star to type class D star. The source type is not polymorphic because there is no virtual function in the base class. So first of all, let's see the code. This is the simple CPP program which will illustrate runtime type identification. So hash include IO string, include this header file, then using namespace std, and this is our class B. In this class we have not written anything, we have just mentioned class B and we have ended this class using the semicolon. Let's say another class, we have derived the class D from the class B. We have derived this class D from class B. We have written class D colon public B, and again we have not written anything in this class D. Just we have ended the class with the semicolon. Main, we have created pointer of class B. B star B is equal to new D. So this pointer star B is pointing or holding the address of object D. And then we have created the object of class D. Star D is equal to dynamic cast D star B. So this is the way to cast the object B and assign it to the D. If D is not equal to null, it will show you it will work. Show you cannot cast B star to D star. You cannot convert the object of B class to the D class. Then close the curly brackets. So this program will fetch an error showing that you cannot cast the, here it is, dynamic cast D B to D star or star D. So let's demonstrate this in the code block. Already I have written the code. Here it is, hash include IO string, then using the namespace std, class B, then class D. We have created this class D from the class B. We have derived the class D from class B. In the main, we have created the object of this B class, B star B is equal to new D. So here it is, this star B pointer, or this pointer is pointing to the object of D, and here it is, we have just casting it to the object D. So this is the way to do this. D star D is equal to dynamic cast D star and B. This B is going to cast into the object D, and if it is null, it will show you works fine, otherwise it will show you cannot cast B star to D star. So just compile the code and see the message. So here it is, at this line you will get the error. At this line you will get the error. And what is the error? Error is you cannot cast dynamic cast B of type class B star to type class D star. Source type is not polymorphic. So this is the way, or this is the happen when you are not mention the virtual function in this, in the base class. So let's begin continuing with the presentation. So you have to add a virtual function to the base class B to make it working. This is the code, same code is there. Runtime type identification, we have included the IO string, we have used namespace std. This is the class B virtual void fun, that is the function. We have mentioned the virtual function in the class B, and then we have closed ended the class B. Then class D colon public B, and then we have ended the class D. Same code is present. B, we have created the object of B class star B, then we have done the casting, dynamic cast, and if it is not null, it will work, otherwise it will show you this cannot cast B star to B star. So this is the code. Again I am going to demonstrate this in the code block. Already I have written this code, and here it is. In this base class you have to mention the virtual function. So in class B we have mentioned the function virtual void function. When you make or add the virtual function in the base class, you can do the dynamic cast. That is nothing but the runtime type identification. And then we have not mentioned anything in this class D, but here it is, we have created the object of B class, or pointer of B class and pointer of D class, and here it is, the same code is present, dynamic cast B star B. So the B gets converted into star D, or it will convert this B into the D. And here it is, if D is not equal to null, saved works, else it will show cannot cast B star to D star. So just save the program, compile it, compile, there is no errors, no warnings, and get it execute. It will work. So this is the way to add or to do the runtime type identification. And only you can do this when your base class have virtual function. So this is called as runtime type identification. So output of the program is works as you have seen just now.